Hello again. In this video, I will show you how to toggle an LED using a push button. I created a new project in STM32 Cube IDE. In this video, I'm using Nucleo-F767ZI development board. According to the datasheet, the push button is connected to PC13, and there's a blue LED that is connected to PB7. If you are using a different board, check your board's datasheet to find the correct LED and push button pins. So I set the PB7 as output and PC13 as input. That's it. Click on this icon to generate our initial code. Our base code is ready. As we saw in the previous video, GPIO is initialized in the MX GPIO init function. Here we have PC13 for the push button that its mode is set to GPIO mode input and PB7 as output for LED. By calling HAL GPIO init, the pins are initialized as expected. To read the input GPIO state, we use the HAL GPIO read pin function. You can find this function in the GPIO HAL library. It takes two parameters, the GPIO port and the GPIO pin numbers, and returns the specified GPIO pin state. In our main function, we write our code inside the while loop. Using HAL GPIO read pin, we read the state of the push button. If it is set, we toggle the LED. To handle debounce, we implement a small delay. Now we can program the MCU and check the result. This method is called pulling. As we can see in the while loop, the processor continuously reads the input state. While this method has its own application, there's another way to achieve the same result more efficiently. We can offload the processor by using the interrupt mechanism instead. An interrupt is a mechanism that allows the microcontroller to respond to an external event without continuously checking for it in the main loop. Instead of constantly reading the button state in the while loop, we can configure the interrupt so that the processor gets notified only when the button is pressed. When the button is pressed, an interrupt signal is generated, and the processor stops what it's doing to execute a special function called the interrupt service routine. After handling the event, the processor resumes its previous task. Now let's see how to implement this in our code. We can configure the GPIO interrupt using CubeMX, but instead I want to write the related code manually. This will be a good practice and help us understand how interrupts work at a lower level. Now let's go step by step and set up the interrupt manually. So we need to add and modify some code. First, in the MX GPIO init function, we change the GPIO initialize and extract mode to GPIO mode IT rising, which means the interrupt will be triggered on the rising edge when push button pressed. Next, we call two functions, HAL and we set priority. This function sets the priority of the push button interrupt. We will discuss this in more detail in a later video. And HAL NVIC enable IRQ. This function enables the interrupt for our push button. The input of the function EXT15 to 10 IRQ is an STM32 specific interrupt number. You can find it in the startup file or the CMSIS device library in this path. When an interrupt occurs, its handler is called from the STM32it.c file. You can find the handler function in the startup file. Now, we need to implement the interrupt service routine in the STM32it.c file. Inside this function, we should call the GPIO interrupt handler. This function is provided in the HAL GPIO library, and it handles the GPIO interrupt events for us. Inside the HAL GPIO EXTI IRQ handler, it eventually calls the HAL GPIO EXTI callback function. This function is defined as a weak function, meaning it has a default empty implementation. We need to define this function ourselves in main.c. Whenever an interrupt occurs, this function will be executed. So I will copy it into main.c and implement it like this. I toggle the GPIO inside this callback function. That's it. Now we can program the MCU and test our code. Thank you for watching. If you have any question, feel free to ask in the comments.